Okay, hello everybody. Thank you for coming. Full house. So I wonder really how many people are in the wrong room. Maybe there's a lot of people in here who don't have a seat elsewhere. I'm going to talk about service versioning in service-oriented architectures and in cloud architectures. Well, this is the only slide actually with the word cloud in it, because my talk is about the services themselves and whether they live in a service-oriented architecture or in a cloud architecture. It doesn't really matter. It's the same for both. So anywhere you see SOA, you can just exchange that for cloud. I also only have a single slide with something on it which looks like code. So all the developers who like to see some code, this is the wrong talk then. So I hope not to disappoint you. It's more about balancing implementations and coding and the problems that you may get in governance. I also show you some techniques on how you do service versioning and why you should do service versioning, why it's a good idea, and some of the things that are missing in service versioning. Who am I? Well, originally I'm from the Java world as well. Don't code a lot of Java anymore, but doing a lot of SOA projects, which are all Java-based. I mainly work for the federal government in Belgium. So I have quite some experience of integrating services in a heterogeneous world. And this talk is actually a repeat of the talk that I gave about 2 months ago at the International SOA and Cloud Symposium in London. So those of you who were there can also leave the room because it's exactly the same. So what am I going to talk about? First of all, the problem of change. Everything in the world is changing, and it's one of the big challenges that people deal with. We have to deal with compatibility issues, and we will see some principles that we can apply to the world of change. I will then talk a little bit about some of the details of service versioning, some design patterns that exist, and some strategies that you can apply. Now, unfortunately, the world is not as simple as just applying some design patterns and strategies. So I will dig into that a little bit on. We'll then get to what service compatibility is when you integrate one service with another one, and when you start changing it. The second part of the talk is about the governance around services. So when you change something, you have to manage that. And the implications of a change can be quite large. You can have, if you're not careful, you can have a cascade of changes into your service landscape. So we'll see the difference between design time and runtime versioning, and also technology versus governance. I'll then show you a practical case, which is an example of the Belgian Federal Government. I'll show you how we can alleviate some of the problems when we do proper mediation between service integrations. And finally, I will end with trying to make a case for standardization around versioning. Versioning is something that is not standardized at all, and is a total anarchy when it comes to development. Everybody does it his own way. So, the problem of change, that's where it all starts. Usually we live in a world where we have lots of services, pieces of code that live out there and do something for you, do something useful. And many of these services are being reused by many clients. That's one of the goals of service orientation, try to make some code that you can reuse elsewhere. But of course, if you start reusing it, and many clients use the same service, then many clients are impacted by a change in that service. So the problem of change is basically trying to figure out what is the impact of the change and how can we minimize impact, how can we move gradually through the changes. Of course, many services depend on other services as well. In this example, you see a service X, which uses a service Z. Where it is deployed doesn't really matter. But if service Z changes, what is the impact? Well, it depends. As usual, the answer is it depends. So we can have a compatible change. A compatible change means that after the service has changed, users can still use it. They don't notice the change. So it's compatible with anything that was before, and all the clients can continue working. That's what we really like to have as a change. But, of course, next to compatible change, we also have incompatible change. An incompatible change is a change that is made to a service and which breaks the contract with existing consumers, clients. And these existing clients, they will have to upgrade their software. They will have to adapt to the new situation. This is what we call an incompatible change. We will get back to that a little bit later. But as you can see here, if we have a service Z which changed in an incompatible fashion, then service X has to change as well, and all the clients using service X has to change. So there is a cascade in changes. But note, I only draw a service here, but in detail it can be anything, any tiny little piece of service contract. If you change that, you will have a cascade of this incompatible changes. So even the tiny addition of a small optional XML element in your WSDL that is describing the service contract can already cause this. So very many people just add a field somewhere and we are in this situation if you're not careful. What we really would like is, of course, we cannot avoid change. Change must be, otherwise we would still be in the prehistoric times. But so change is a good thing, but we have to make sure that all the people that use our services, that for them the impact is not too large, and that we make it a pleasant journey for them as well. We don't want to change them all at the same time. So we would like to get to this situation where we have a gradual change of all the clients. So some clients, in this case client 1, is still using the old version X, and clients 2 and 3 already are using the new version. So some general versioning principles. In general, we don't want clients to be forced immediately to use a new version of a service. Just be nice to your customer. Usually when we are in the private world and you have a service somewhere sitting in the cloud, you want it to be available to your customers. The customers pay for the use of your service. So you don't want to force them and be unnice to them to have extra costs in order to use the new version of the service. So we don't want to force them. We want a gradual client migration and retire old versions of services gracefully. Now, this automatically means that we need to find out a way to have multiple versions of a service in place concurrently. So the old version and the new version must be available at the same time. Of course, we don't want to do this for all the previous versions that may have existed in time. So we have to limit somehow the number of versions, usually 2 or maybe 3. But at least you want to avoid the Big Bang approach. New customers to your service, you only want them to use the latest version and not an old version. So when it comes to discoverability of the service, you only want them to discover the latest version, right? So you see at the bottom there's a transition period for using an old version and migrating to a new version. Okay, some design patterns. There's a very thick book. It's down here in the bookstore as well, with design patterns about SOA in general, and only 4 of them have anything to do with service versioning. So that's not really a lot. And these are the 4. Canonical versioning. What does it mean? It basically says that you should have some kind of standardized versioning method within your whole inventory of services. So you have a whole inventory of lots of services, and what we want is that the service versioning mechanism that you use is the same for each service that's in there. That's all it says. It doesn't tell you how you should achieve this. It's just a good idea to do. Then there is the pattern of concurrent contracts. A single version can have multiple contracts. You can have a single implementation and multiple WSDLs, for example, that you expose to the outside world. In this way, you can also have contracts that are explicitly targeted towards specific clients, customers, or maybe different specific usage. For example, like versioning. You can have two different WSDLs, one for an old version and one for a new version, and behind it could be the same implementation. Of course, when you do these kind of things, you have to design that from the start. It's very difficult to do this with existing code. So you have to take these considerations of versioning into your development of the code. Then there is a pattern of compatible change. That's what we would all like to do. We would like to make new versions of services without breaking the contract for consumers that use the old version. This is extremely hard. It's a very simple design pattern, but it's very hard to do. Most of the changes that we make, they break contracts. And then, of course, there is the design pattern of the version identification, maybe the simplest of all and and very well known. It basically says that every version should have some kind of number. And we all know the numbering system. Major releases, minor releases, point releases. The latter ones are just bug fixes and small enhancements, where the major releases, they are certainly not backwards compatible. And they could, for example, also be a major change when you have a major functional change. So the contract may be not changing, but if the functional change inside the service is changing, you may also opt for a major release. So that's very well known, but still doesn't tell you how you do the versioning for services. There is a book in the same series of SOA talking about service contracts, and it has even the word versioning in the title, but there's only a tiny piece of it that is actually dealing with versioning, and it's a bit disappointing to read because it still doesn't tell you how you do it. It does give you 3 strategies, strict, flexible, and loose strategies, and you should be aware of which strategy that you use in your service inventory. That's important for your clients to know as well. So there is a strict strategy, which means that for every incompatible change, you make a new major release, and the compatible change, you make a new minor release. I think this is what most people do. It's not always the best solution, but it's a simplest solution. The loose strategy is that everything that you change and is incompatible is a major version, but the rest you just don't care about. You just do as if it's the same version. And then there is the flexible one, which is in between. But in practice, most of the service changes are incompatible changes, which means that the strategy that you choose doesn't really matter. Incompatible changes are always major releases. So you will end up with a lot of major releases, even though you think you are doing minor releases. Very often they are major releases. And I'll explain why a little bit later. So when we change a version of a service, we would like to have it compatible with the previous one. Now, believe it or not, in XML, which is usually used to describe the contract of a service, there exists something like forward compatibility, which means that the current version, or the users of the current version, can use any of the future versions as well without breaking the contract. You can do this using extension points with XML schema, but it's very complex, especially if you have a few if you have a few versions after each other. Then your extension points go deeper and deeper into the tree of XML, and it's very difficult to keep track of all this. Also, your XML doesn't really look nice anymore. It doesn't give you an association with your real business objects. It's ugly. So it's very complex, and though it theoretically exists, personally I've never seen it used. Maybe somebody in the audience uses this, but it's hard. Anyway, if you could use it for simple cases, for example, then I think you should, because it's good for your clients. Backward compatibility means that a newer version is compatible with today's version, but it doesn't mean that existing clients can use the new version. That's unfortunate. So existing clients, they have to adapt their code in order to use the new version of your service. Now, in a service landscape, if you really build services, they have a lot of service principles behind them, like they must be agnostic in the way for the way they are being used. It also means that a change in a service is not only in the technical contract, but also in the functional aspects of a service. So, in a service landscape, compatibility covers all aspects, including the functional ones. Okay, so if you make a lot of changes functionally to a service, compatibility is becoming an issue already. A very short note about rule-based contracts. It goes there. You can have a complete separate talk about rule-based contracts. It's not very common. Services, they have contracts in a functional way and in a technical way. The technical contract is the WSDL and the XML schemas usually. That's what we call grammar-based contracts. The whole language of XML is written in that single WSDL with associated XML schemas. Rule-based contracts, you don't see that very often, but it doesn't tell you how the XML really looks like, but it tells you what kind of information is in the data, in the XML. For example, a set of XPath expressions can be a rule-based contract. It's much more flexible than grammar-based, but unfortunately, because it is so much flexible, there is very few frameworks, or hardly any framework, that is being used by Java developers to actually make the Java to XML binding. So grammar-based compatibility, in grammar-based, it defines exactly how the service communicates. So it's a protocol specified, and all service clients have the same compatibility contract. So WSDL and XML schema are the best known examples for this. In rule-based, it's a bit relaxed. Each service client can have its own compatibility contract. Each client can basically have a set of XPath expressions defining what he needs from the data from the service. An example of this is schematron, very, very powerful, and I wish that XML schema did not exist and all the contracts were already based in schematron 10 years ago, but unfortunately it's not. But if you have some interest in this, then go and have a look at it. So, implementing services in a grammar-based way with WSDL and XML schema is more or less a design time issue. At design time, you decide what the contract looks like. So, if you want to do some versioning, what a lot of people do is to design at design. Well, in design time, they already state what strategy for versioning they are going to use. So, for example, a fixed version value is somewhere in the technical service contract, in a grammar-based contract. Like version identifiers, I've seen a lot of cases where this is done in the namespace of the XML. This is very simple from a Java point of view. What you see is what you get, so basically what comes out of it is directly usable. Seems very simple governance, at least from the development point of view, but not from the business point of view. New versions, if consumers want to use a new version in this case, the client has to recode and update everything, and make a new deployment, do all the testing again, etc. Very hard. Runtime versioning is different. There's no fixed version value. There is, of course, some kind of element somewhere which can hold a value for a version, but it's not fixed. That's the important thing. If you're not fixing it, you have to test at runtime actually what the value of that field is in your XML, and you have to make decisions, versioning decisions based on that. That's why it is called runtime versioning. In design time versioning, you don't have to do that. You can design on beforehand where your version is. So runtime versioning, although it's more flexible because you can put anything in that version field, you must, the governance for it is a bit more difficult. You have to handle it. You have to be able to give exceptions, for example, to those versions that don't exist, or clients that want to use a version that they are not allowed to use. You have to do all that. But if certain clients want to use a new version of the service, then at least clients that maintain with the old version can be handled by the same endpoint of that service. The runtime is more it maps more onto the governance of services, and the design time maps more onto the technology, onto the development of services. WSDL and XML schema, they are very, very popular, very well understood, and you can impose a versioning strategy by it. And of course, there is lots of tools that can deal with it. Everybody can generate Java from XML, and vice versa, you can generate XML from Java. Sounds great, but in practice, when you start integrating this, it's a nightmare. On the governance side, so if you do runtime versioning, you are dealing with organizational processes. First you have to look up which value of the version is requested, and then you have to do something with this. That doing something with this very often is associated with organizational processes that are less well understood. You have to have service level agreements with many clients of your service. You must define the versioning strategy in a soft document. You cannot fix it in the XML schema in this way. Of course, there is also no tool support for this, and there are no standards. And if you do governance of services, you have options like service repositories, but they're all proprietary software. So it's no open source, no standards around them. So you spend a lot of money, and you put all your business data in these proprietary service repositories. So in real life, we very often see that some kind of endpoint URL for a service contains some version number. We have version 1 is there, version 2 is a different endpoint. We also see that most common is grammar-based service contracts, WSDL and XML schema, and we very often encounter either version numbers in XML namespaces or some element with a fixed value for a version. And the last bullet point here is that only a single service version is in operation at any one time. That's what we see in practice. It's not a good thing to do. So I'm sure that there are people in the room who do it properly and can have multiple versions at the same time. But that's a minority, at least, of the services that I've seen. If you have a single database, for example, and your database schema is changing, it's not so easy to have the code on top of that, being able to deal with both the old schema and the new schema. So even a small change in the database schema can already trickle up into the whole service world, into your client usage. That's what we call a big bang approach, because all the clients have to change if you change your code. All the deployments, usually what happens is that there is an email going around on date so-and-so at time so-and-so. We are going to upgrade our service. All consumers, all clients, they have to do the same at the same time, which is not very nice if you have many clients. And if those clients have other clients, then you see what I mean. It's not so friendly. So in practice we see a lot of WSDL and schema. Most of the changes are also incompatible changes in grammar-based contracts. Even adding an optional field in the response message is already breaking the contract. This is something that a lot of people think that if I add an optional field to my WSDL, that's optional, so I don't break the contract, it's backwards compatible. Well, it's not. It's backwards compatible when you just look at the XML schema, but when you exchange those data that are based on the schema, the other party can suddenly receive some kind of element or attribute that he didn't receive before and never expected. So that can break his contract. Of course, if you add an optional field to the request message, then you're safe. That's backward compatible, but not in the response. And most of the time when we do services, you request some data, and the data when you request it only has a few parameters, the search criteria, but when you get something back, you get an enormous amount of data back, which is all your object model basically that you request. So most likely that any changes occur in the response message and not in the request. So it's very likely that you deal with an incompatible change. Updating a hard-coded XML namespace is also breaking the contract, of course. Some people say that's good because then I have a new version of the service and everybody must start using the new version. But in practice, this is also a very, very difficult thing to do. There is one government agency, I won't call it by its name, in Belgium, and it has release 18 at the moment of software which has XML schemas. It's a huge pack of XML schemas. But in the namespace, the version identifier is still 1.0. And why is it still 1.0? Because it's so hard to update it. Okay, so all the clients have to change as well if you do this. So some words about the world that I live in, not on a daily basis, but on a regular basis. In the Belgian government, we have authentic sources. We have a federal service bus as a mediator between everything. And we have government agencies that use these data. All of the agencies and the authentic sources, they are different organizations. Not the same people, different ideas, different technologies, etc. And the federal service bus in the middle, that's the thing that tries to connect everything together. So authentic sources, that's what we call the big databases where all the data of specific usage is maintained. The three most important ones, the National Register for Person Data, contains all the information about you and me and everything, at least for those living in Belgium. Then there is the Crossroads Bank for Social Security, containing all the social security data, and for enterprises, containing everything about companies. All these authentic sources, they maintain their own data, they try to keep everything consistent within the database, and they make these data available via web services. And of course, these data are relevant to very many government agencies on all kinds of levels, federal, Flemish, Walloon, etc., even local level. So there is this federal service bus in between that tries to expose these services in some useful way. So how do these authentic sources do their versioning? Well, all of them only maintain a single concurrent version. So that means that at some point all these web services, they are updated on a regular basis, some every 3 months, some every 4 months. Sometimes there is a bug fix which goes in between. But there's only a single concurrent version, which means that all the clients using these data must update at the same time, which is of course a governance nightmare. So all of them, they have Big Bang versioning. You get an email on beforehand when the Big Bang is going to happen, and then everybody is ready. And then the next day, everybody is praying more or less that nothing goes wrong, because if you have to do a rollback to the previous situation, I'm not sure if that has ever been tried actually, but it can be very difficult as well. So both Social Security and the enterprise databases, they use version IDs hard-coded in the namespace, but both are at 1.0. And the National Register, they have a fixed value in a version attribute, which is slightly better, but not good enough. So because the lower ones, they all do the Big Bang versioning, we don't want all the government agencies to change at the same time. So that's why this mediator is in between there. It's a service bus. It's called the Federal Service Bus. I'm not going into the details of all the technologies and infrastructure underneath, but at least it's something that connects to the authentic sources and can apply data transformations in such a way that we make life a little bit simpler for the agencies. So they are shielded from the Big Bang effects in a best effort, because sometimes we can't avoid it, but it's a best effort case. So Big Bang is not really very nice. If you use mediation, you can already make this a best effort case, so you can make life a little bit easier for the clients, so you can minimize it a little bit. But in the end, the problem arises with the source. Because the source doesn't do versioning in a proper way, that trickles down and it's a cascade of changes to everybody else. And we are now living in a world where more and more people are using these services, more and more agencies are using the services, so every change is going to cost more and more money. It's not, it's a government, so it's the total cost across all the agencies that really matters. We pay taxes, that's where our tax money goes to. So we want to minimize all these Big Bang scenarios, and we want to minimize the effect of change. So one of the things that should be done is to design by contract. Contract first, and then and not contract last. What does it mean, contract first? Basically, you make the WSDL and your XML schemas, your data exchange protocol, you fix that first. That's the business. And then you try to match that to the underlying data. Of course, that means data transformations, but that's the way you can avoid a lot of the changes. On the contrary, what we see is most of the time is contract last. What does that mean? Contract last means we first make the code, we then press a button, generate the WSDL, and we automatically have a WSDL and schemas, and everybody can use that. But a tiny change in the code somewhere, again, it's a cascade effect in your Java code, and your WSDL will change, and all the clients will be affected. So contract last is not a good idea. Contract first is a lot better practice to do when you want to reuse your services. Then the hard coding of version numbers and namespaces. I'm not sure why this is done. I have no idea. I think there's no Java developer who will code a version identifier in a package name. But somehow in namespaces in XML, people think that's more normal. I don't know why. But don't do it. Neither should you fix them in an element or an attribute. Just make it a string that you can allow to evolve. That's a lot simpler. Of course, simpler, but you have to govern that. Huh? When using runtime versioning, it's also a lot better than design time versioning, because in design time versioning, the clients that use your service, they couple themselves tightly to that versioning strategy that you choose. If you do runtime versioning, you have the ability, at least using governance, you have the ability to change that strategy in the future, or to make things a little bit easier for your clients. And rule-based rather than grammar-based contracts, that's also a good idea, but it's hard. please take a look at schematron and how you do that, and XPath expressions. But it's not simple because of the lack of the frameworks. Okay, so then mediation is also a very good idea to actually shield some of the problems that exist at the source from your clients. So put a mediator in between when you go to do service versioning. Mediation strategies. We have a few different options here. We can do context-based routing and we can do content-based routing. And what that is, I'll briefly explain. Context-based routing basically means that it's not the service itself who knows about the version of the service to call. It's the context in which it is used that decides which version is used. Very often we see this being done by using a different endpoint, a different URL for each service. That's a very common way to do so. In this way, it's the client who actually decides which version he is going to use. If you have a new version of your service, then you make a new proxy for it, and the consumer has to adapt to that new version. He has to at least change the URL. That's the minimum that is required. Content-based routing, we have two options there. We have, in this case, a single endpoint for all of the clients. So there is a single entry into the service, and that entry point, there's no indication of which version of the service that is requested. The routing can be decided by either the client or the mediator, depending on whether he passes a client ID or a version ID. If you choose your strategy to use version IDs somewhere in the message, then it's the client who decides where to route to. Otherwise, it's the mediator. In this case, if you have a new version available, here, for example, at the bottom, version 2, all the clients that are still using version 1.1 can continue using it. There's no impact for them. The endpoint stays the same. They don't have to do anything. This is a very friendly way of doing versioning. So we have the two categories, version ID or client ID. In the version ID case, it's the client who decides again which version he wants. But if he wants to use a new version, he has to update the version ID element, or the value that is stored in the version ID element, which means he has to do some kind of configuration or code change. When you do a client ID, then the client just sends an ID to identify itself, which is very often can be taken from a certificate or so that he uses to sign a message. And it's the mediator who decides which version is then used. That version that is being used, of course, you have to agree with your client which version he wants to use, and that is written down somewhere in a service level agreement, or at least some kind of soft document. So it's not hard-coded anywhere. This way is very flexible. The mediator has all the power, and version changes have no impact on existing clients, which is very good. But as I said, you need a good service usage agreement where this is defined. That's a soft document. So that means you need governance for that. You need to manage that. There's no way that within the code you can test that particular case. So now I would like to make a small case for some standards around versioning. As we've seen, if you start mediating version changes, then you are much more flexible and you can be much friendlier towards your clients than if you don't do that. So versioning really is an aspect of service orientation. So it could be implemented as a policy. Really, I don't know why it doesn't exist. There's no such policy. Security policies exist. There are other things like transactions, reliable messaging, and so on, but not for versioning. WS addressing is the closest thing. That gives you the possibility to at least have some routing information of where your request or your return or your response message should be going to. So you could use that as some kind of versioning mechanism, but it's not really the same. What we would need is some kind of WS versioning standard. I believe that this is not too difficult to do. So it could define, for example, whether we do context-based or content-based versioning routing. You could define some SOAP header elements, for example, to do the mediation. The endpoints, client identifiers, service version identifiers, and all these kind of things. That could be standardized, and then you could, of course, have the application server where your service is running in handle all the versioning. So you have the mediator basically within your application infrastructure or your service infrastructure. You don't need a separate service bus for that. Of course you can, but if you would have standards, the vendors of all the application servers, they will probably implement it. In this way, you can always have an abstract endpoint for your service. For example, here I give some my service URL, and the specific endpoint of the version is only known to the mediator. It's some kind of local protocol, and it only needs to know locally where the version of the service is. And if you only need to know that locally, you can do dynamic binding to specific versions. That's what the mediator can do. And this is the only slide. I promised you I had at least one slide that looks like code. There's some WSDL and some schema import. These are small snippets from larger schemas and WSDL. In both XML schema and in WSDL, there is one place where there is some hard-coded stuff in, and that's the location and the schema location of where to find any imports. So in WSDL, for example, the location is the endpoint of your service, but it's hard-coded in there. There's no way of actually making that part of your code. The same with schema location. I can change that if I move around the files of my imports. I can simply change that, and it doesn't make a difference to any of my code. So these are hard-coded things which shouldn't really be there. What should be there is some kind of abstract endpoint and some abstract path to your schema location. It's like, compare this with the deployment descriptors that we had in Java already a long time ago, where all the hard-coded things are just are taken out of the code and put in the deployment descriptor. That's not done here in XML, and I think that's a pity. But if we could change this, and if we could put some kind of variables in there or abstract endpoints and abstract schema locations, then you could do some dynamic binding within your mediator. It allows you then to have the imported versioning, the imported version schemas. You can then import them directly from source control systems, things like Subversion, or Git, or UDDI repositories. The mediator could actually figure out that if it gets some kind of schema location, if it has some kind of schema location, and it's an abstract one, together with the client ID that is passed on by the consumer, these two are sufficient for a mediator to know exactly where to find a specific version of that schema that he is requesting. In that way, what you would like, if you try to be nice to your clients, then you would also like to have something like !WSDL to a service endpoint URL. If you do that now, you usually get the WSDL of the service. But what you also could do is, for example, !versions in order to get a list of existing versions of that service, or pick the specific WSDL for a specific version. So the mediator decides all these kind of things, and we could do a lot of we could make versioning life easier if we would have standards around this, and if we would have mediators that actually come within the service infrastructure. So, I have 11 minutes left, I see. So the conclusion, service contract versioning is to a large extent a governance issue and not really a development issue. It's in development, it's very easy to come up to generate whistles and schemas and so on, but the real issues when you start changing things come with the contract and the governance of it. So we've seen the difference between runtime and design time there. It's simpler when you use rule-based contracts than grammar-based contracts, but again, unfortunately, we are stuck with WSDL and schema for a while, I suppose. A lot of the changes that are being made to services are actually incompatible changes, even though people add some optional field somewhere. And we can actually support all the governance of services and service contracts, versioning. We're using a mediator, using a repository for all the versions, and some policy enforcement. And for that, in order to do that, we need the WS version standards for SOAP web services, at least. You can extend this into RESTful services and to for rule-based services, but I concentrated right now to the most common case for grammar-based services. Okay, that concludes my talk. Maybe there are questions, maybe not. No questions? I can't see you, so there's a lot of lights. Let's see if here.
One question. Is the mediator has all the business knowledge also to arrange the contract, to select the right version?
The question is if the mediator has all the knowledge about picking the right version. Well, the answer is yes. The mediator is needed for actually picking out the right version. So it must have the knowledge of client IDs, for example, version IDs, and these kind of things. Yeah.
Because mostly it's between the consumer and the provider.
Yeah, it's between the consumer and the provider that these contracts are made. But in this case, you would need soft documents, service level agreements that actually describe these kind of things. So you need governance to do this. So mediator is only doing the technical part, but of course you still need governance to actually couple the client to the service provider and the right version there. Yes. Any other questions? One over there.
You're focusing mostly on web services, but REST has the same versioning problem. What are your thoughts on libraries like Drift, Protobuf, and Avro to tackle version problem?
The question is about RESTful services and some of the frameworks that exist there for tackling versioning. I don't know. REST is intended to be very flexible and very open, and no contracts. So I think again you need a lot of governance in that case to actually make it work. Any other question? I have there's a question there.
What do you do when you are required to include the version not only in the service, but in all the schemas that are included?
Can you repeat that? I couldn't.
When you are required to include the version not only in the service, but in all the schemas that are included.
Yes.
What do you do in this case? Because
What do you do? Well, you have a lot of. If I understand it correctly, you ask if you have all these schemas and imports and everything, and there is somewhere.
each schema is version, even the subversion can change and have an impact.
Yes, so all these schemas, they would have their own version. So each schema is in a separate file, and in the name of the file you can, for example, define the version number, and you can then do the imports, the picking of the right version from a GitHub, for example, but the picking of the right version must be done by the mediator. Yeah?
Yeah, I have a question because you mainly addressed the issue, like looking at the vendors of services, but what about protecting the client? I mean, do you have some hints how to protect the client in case of contract changes?
The question is how to protect the client in case of contract changes. Well, being friendly to the client, but sometimes you can't. You have to, for example, in the government, sometimes the law changes, so you have legal issues. You must change your service. In that case, you need governance in order to update all your clients as well. So you can't always avoid it, but I think you can make life a bit easier. Yes? Well.
All the industry standards defined by W3C and OASIS express versioning in namespaces.
Yes.
Did they all make it wrong?
I think that's wrong, yes. I know, and it's probably from there that it arises that people use a version number in a namespace. But in Java, for example, nobody uses a version number in a package name. No, it wouldn't come to mind. So why would you do it in XML? And of course, in W3C and Oasis, they define schemas about XML. So it's the basic schemas that exist. And these schemas don't change very often either. So if there is a hard-coded version, that's usually the data. It's a year and then a month. So if it's a hard-coded version in there, it doesn't make that much difference because it takes 10 years before the next version comes out. But in our daily lives, that's not good. So I think it's wrong. There was a question here as well. Yes?
Yeah, I would challenge the two statements that you make, that nobody uses versions and package names.
Yeah.
So when we do exactly the strategy to program concurrently multiple versions, the fronting interface before the common business implementation, actually in our cases, often has the versioning in the package names. And the other one is, what's wrong with putting the major version in your versioning strategies into schema namespaces or versions or whatever? What's wrong with incompatible schemas having different namespaces?
The thing that is wrong with incompatible schemas having different namespaces is that it's not wrong if you have some service that doesn't change very often, for example. Then you can manage that. But if you have a lot of changes, for example, you have a WSDL with version 1 in the namespace and it imports some schema with version 1 in the namespace, which imports another schema with version 1 in the namespace, which etc. And you change something in the lowest XML schema, which is not backwards compatible, then the next schema, which imported that one, must be updated as well, because it also becomes incompatible, etc. It becomes incompatible. So the problem is that in this case, you end up having to change that version number in the namespace extremely often. And it's a cascade effect, and it can be from just one tiny little thing deep down the tree. And that means also that if your XML schemas have to get a different namespace, your WSDL will be a different namespace. All the clients using the service will have to use a different namespace. What will they have to do? They will have to recompile the code. They will have to, even though maybe for them, if they don't even use that field, they still have to regenerate their Java code from the XML, and that becomes unmanageable if you talk about a lot of clients. Of course, if you only have a single client using a service, that's not really an issue because you talk to him and everything is fixed. But if your intention of a service, especially with cloud services, is reuse, then this is a big issue. And then your other point was that you had an example where you use version numbers in the package names. And then my answer is that, well, maybe you should use a mediator for that as well, no?
Sometimes we do.
Okay.
Sometimes it's not possible
All right.
without extra coding.
Okay. Another question is?
You mentioned the problem of trickling up of changes.
Yeah.
So we were looking at tools to do this an impact analysis.
Yes.
Little changes and doing an intelligent tip of XML schemas that doesn't complain about changes that are not used. Because
Mm-hmm.
but we end up writing this tool ourselves. Do you know what
Okay, so the question is, do you know of any good tool that can do an impact analysis if you change something here? What is the effect on there? Well, the answer is we are also writing a tool ourselves, because it's not a simple problem. We have a tool. It's not production ready at the moment, but we do have a tool. It uses a graph database underneath to actually do traversal up the way up, but it's a different topic. Okay, and do I have time? Because there is another speaker, I think, afterwards. Time's up, it says. So maybe the next ones with questions can come down.